Hello everybody, welcome to Mathethics original channel. Thank you for watching our videos. Please don't forget to like, share and subscribe. In today's video, we will just answer some questions about quadratic function application. Some of them are dealing with tables and some of them will be using graph to analyze the quadratic function. So let's begin. The first question we have is, Nisa made the table below to show the relationship between the side length and the area of various poster boards. So what is the relationship between the area and the side length in the table? Okay, so that's the table we're talking about. So this side right here is the side length in feet, of course, and the area on this side is in square feet. So first of all, we need to know what type of function we are dealing with. Okay, so the fact that they're talking about area here, so we know area is always, every time they say area, we always refer to quadratic function. Okay, so I already know this is a quadratic function, the fact that they're talking about area. Okay, so now let's say you didn't know, you couldn't tell what type of function that is. So the other way we could figure that out is by checking to see if we have a first difference or a common difference or a second common difference or a common ratio. Okay, so that will tell you what type of function you're dealing with. Okay, so let's see if we have a common difference. The common difference means that single number you add from the previous term to get to the next term. So now let's see, what do we add to 1 to get 4? So 1 plus 3 is 4, so we add 3. So we add 3 here to get 4. And then what do we add to 4 to get 9? So 9 minus 4 is 5. So we add 5 to 4 to get 9. And then 16 minus 9 is 7. So we add 7 to 9 to get 16. So now notice that the number changed from 3 to 5 to 7. So therefore it's not a linear function. Okay, so if the number was the same, either like all three of them was 3, 3, 3 or 5, 5, 5 or 7, 7, 7, so we would claim that it's a linear function. But the fact that the number changed from 3 to 5 to 7, then it is not linear. So, and that would be the first common difference. Okay, so that would be the first common difference. So now what we can do, okay, so that we will say this is the first common difference. Okay, so again, in order to claim that it's linear, the first common difference have to be constant. All right, so since it's not constant, so it's not linear. Now let's check to see, let's check for the second common difference. All right, so the second common difference, what you do is use the first common difference to find the second common difference. Okay, we do the same thing to find the first common difference. That's the same thing we're gonna do by using the first common difference. So what do we add to 3 to get 5 is 2. So that's 2 here. And what do we add to 5 to get 7 is also 2. Okay, so this right here is the second common difference. All right, the red one right here is the second common difference, and it is constant. All right, notice like the 2 doesn't change. Okay, we have 2 in both of them, so the second common difference is constant. Because the second common difference is constant, then we can claim that it is a quadratic function. Okay, so remember, if the first common difference was constant, it would have been a linear, but because the second common difference is constant instead, then it is a quadratic function. So now we know we are dealing with a quadratic function. So what is the standard form? So what is the standard form of the quadratic function? Okay, so remember, the standard form of the quadratic function is f of x equal ax squared plus bx plus c. Okay, so f of x equal ax squared plus bx plus c. Now, what we need to find is the a, the b, and the c. Okay, so once we find the a value, we check. Okay, so once we add the a value, so the x squared, the whatever a is gonna be in front of x squared. Whatever b is gonna be in front of x, and whatever c is gonna be by itself. So once we find the a value, we check the table. So if it doesn't satisfy the table, we look for the b value. Then when we got a and b, we check the table again. If it doesn't satisfy, then we look for the c value. Okay, so let's first find the a value. So now, how do we find the a value for the quadratic function? Okay, giving a table. So the a value is equal to the second common difference divided by 2. So we take half of the second common difference. So in this case, the second common difference is 2. So we're going to have 2 divided by 2, which is 1. So therefore, a is equal to 1. Now, since we are talking about the side length and area, so we're going to call, instead of x, we're going to use s. Okay, so we're going to say, well, the area, and we're going to use a for area. So we're using a for area. We can say the area is equal to 1 s squared. Now, the s stands for x. Okay, so instead of putting x, so I use s for the side length instead of using x, and I use the a for the area instead of using f of x. Okay, so 1s squared is the same thing as s squared. So the area is equal to s squared. So let's see if that's work. So if the side length is 1, so then the area will be 1 squared. So what is 1 squared equal to? 1. So that's checked. If the area is 2, then if the side length is 2, then the area will be 2 squared. What is 2 squared? 4. And that's checked. If the side length is 3, then the area will be 3 squared. And 3 squared is, 3 times 3 is 9. And that's checked. If the side length is 4, 4 squared is 16. 4 times 4 is 16, and that's checked. So that satisfies the equation. So the relationship between the area and the side length, therefore, will be a equal the area is the side length square. And that's it. Okay, so that's it right here. Now, so that's it right here. So let's now go to the second question. In the second question, they say the table shows the diameter and price of different circular rods. Choose the equation that correctly relates the price P of each rod to its diameter D in feet. Okay, so this is the diameter of the circular rod. So that's the rod that's in circle. Times the circular is circle. So that diameter is in feet and the price is in dollars. So they want us to choose now. The good thing here, they give us some answer choice, and they want us to choose which one is, which one will describe the relation between the diameter and the price. Okay, so the best way, the quickest way to do this one right here is to check if you take 8, because we got some answer choice here. So if we have 8, we plug 8 over here. Okay, so we're gonna check for each one of them. So I'm gonna do with the first one. Okay, so if P equal to d squared, right? So P is the price and D is the diameter. So if the diameter is 8, okay, if D equal 8, then P equal 2 times 8 squared, right? So 8 squared is 64. So equal 2 times 64. And 2 times 64 is 128. 2 times 4 is 8. 2 times 6 is 12. So that's 128. Okay. So, and when we look at the table, when the diameter is 8, the price is 164. So that means this one is not good. Okay. We're going to put a cross on it. Boom. So it's out. Let's check the second one. If P equal 2D plus 4. So now, if D is 8, if D equal 8, then P should be equal to 2 times 8 plus 4. And 2 times 8 is 16 plus 4. And that'll be 20. Sorry, that'll be 20. And we see when it's 8, it's supposed to be 164. So therefore, this one is out. Let's check the third one. So P equal to D plus 16. So if D is 8, if D equal 8, then P equal 2 times 8. So everywhere I see D, I'll replace it by 8, right? So plus 16. So 2 times 8 is 16. And 16 plus 16 is 32. And again, so that's not true. So this one is out. And let's check the last one. P equal D squared plus 100. So if D equal 8, then P equal 8 squared plus 100. 8 squared is 64 plus 100, and that's equal to 164. So that's telling me this is the answer right here. Okay, and we can check a couple of them. So if D is 10, then 10 squared is 100. 100 plus 100 is 200. So that's also work. And if this is 12, if diameter is 12, 12 squared is 144, and 144 plus 100 is 244. So it's work. So that's your answer for number 2. All right. Now, question number 3. Say John and Calvin are tossing water balloons from the roof of a shed and videoing them as they fall. They have collected the following data. So we're gonna write the explicit formula, or the explicit form of it for h of t. Okay. So again, all we have to do here, this is we got some option here. It's a multiple choice question. We have to select the correct answer for the table. That's match the table. And again, the easiest way to do this is, you can check a couple numbers, and I'll take the whole numbers. I'll check some of the whole numbers and just to make it easy. So if x is 0 on the first one, okay, so let's say h of t. Let's say h of t so let's say h of t equal h of t equal negative 2x plus 7. So if t is 0, now let's check something with the 0. If t is 0, part A is true, so negative 2 times 0 would be 0. 0 plus 7 would be 7. So that will be true. And it will be also true for this because 0 squared is 0. Negative 2 times 0 is 0. 5 times 0 is 0. So it will be true also for this. And over here, however, if h of 0 is 7, so h of t equal h of t minus 1. So the previous term plus t, which means h of 1 should be equal to h of 0 plus t. So plus 1. So h of 0 is 7 plus 1 is 8. So it's not going to work. So we already see this one right here is out. Okay. So now for this one, h of 0 work for everything. Okay, so that's all for everything. So let's see if h is 1. So if time is 1. So if t equal 1. Okay, so if t equal 1, then I'll have h of t equal negative 2 times 1 plus 7. And negative 2 times 1 is negative 2 plus 7, which is equal to 5. So it doesn't work for this one. So that means this is not the solution. This is out. So let's try the second one. Let's try the second one is h of t. So I'm going to use a different color for that. So h of t equal negative 2 x squared. Well, it's supposed to be negative 2t squared plus 5x plus 7. So there was a mistake here, I believe. In this question, this is supposed to be t, okay, because the function is expressing in t. So all this while he's supposed to be in t. All right, so let's fix that. So these are t. So I'm gonna fix it over here as well. 2t squared plus 5t plus 7. Now, if t is equal to 1, okay, if t is equal to 1, if t is equal to 1, then h of t would be, everywhere you see t, replace it by 1, so negative 2 factor of 1 square. So I put this in parentheses just because if t is negative, so I put everything inside the parentheses. So like this, I can just plug it in the calculator the way it is. Okay, plus 5 times 1 plus 7. 1 square is 1. Negative 2 times 1 is negative 2 plus 5 plus 7. And negative 2 plus 5 is 3. Got 3 plus 7. And then that's equal 10. So is that true here? Alright, so that seems to be true. Before we go further, let's check to see if that will work for the third one, for the last one. We already know c is out, okay, so let's see if it's gonna work for the last one. Okay, so let's see if we have, we're gonna use a different color here. If we have h of t equal 2t squared minus 5t plus 7. So if t equal 1, then h of t equal 2 times 1 square, okay, minus 5 times 1 plus 7. So 1 squared is 1, and 2 times 1 is 2. Minus 5 plus 7. 2 minus 5. So 2 minus 5 is negative 3 plus 7, and that'll be 4. So that's decimal. So at the end, our answer will be this. Okay, so is that you just go ahead and plug in some numbers and then see which one is satisfied, and you'll get your answer. Like now, here's another question. So this question right here, the function h of t equal negative 16t squared plus 75t plus 80 model the height in feet h of a ball as it is thrown into the air at time t in second. So what is the height of the ball after 5 seconds? Okay, so now that was the question. So what I did here is I went on Desmos and then graph it. Okay, so my student already know how to do that. So I went on Desmos. I was trying to do it here live during the video, but I couldn't download the app. So I went on Desmos and then grab that function and select those points so we can talk about it in the video. Okay, so it's pretty simple, it's quick, so you don't have much to do. You just type in the function, go on desmos.com and graphing calculator, and then you just type in the function the way it is, and then it will give you the graph, and then you can kind of play around with it, and so you can see the full graph. Now, so the question is, what is the height? Okay, the height of the ball after 5 seconds. Okay, it's like you take the ball, you throw in the air, like especially for basketball when playing. So the it's always have a curve, and that curve we call it a parabola. Okay, so remember the graph for a quadratic function is called a parabola, and that is a curve. So now we have a parabola here. So when I put this in the calculator on Desmos, when I put the function on Desmos, I got this curve right here. So I know it's a parabola is the graph for the quadratic function. So now the time is the x value. Okay, so every time you see h of t, f of x, you know, m of something, so every time you see something that's look like this, is the same thing as the y. Okay, so this side right here is the same thing as the y value. Okay, so if this is the y value, so this variable, and that's what we call the dependent variable. Okay, so the y value is a dependent variable. So this right here will be the x value, the x axis, right? So that's the independent variable. X is always the independent variable. So our t value will be here, the time, which is time, and the y value, which is the height of the ball, so will be right here. So now the fact that the curve is open down, so, okay, it's open down, so it's like a U upside down, so we have a maximum. Okay, and anyway, every time you throw something in the air, we always gonna have a maximum, because the curve that's gonna be formed gonna be a U open down. So because when you throw something in the air, it's go up and then it's go back down, so it's gonna be a curve that's open down. So therefore, so we have a curve here, and we need to find out what is the height after 5 seconds. Okay, that's 0 second, 2 second, okay, 0 second, 2 second, 4 second, and 5 second is somewhere around here. Okay, let me see if I can work on this. So that's 0. If that's 2, then that'll be 1. Okay, that's 1 second, 2 second, and that'll be 3 second, 4 second, and that'll be 5 second. No, is that right? No. And that'll be 5 seconds. So 5 seconds. So when I grab the 5 seconds here, so you can see it's happening right here. My line is not straight, so it's happening right here. So when I click that point on decimals, so show me, well, 5 is 55. So then that's the height. So that's the time in second, that's the height. So I will say at 5 seconds, or after 5 seconds, the height is 55 feet. Okay, so in mathematically we can say h of 5 is equal 55. Okay, so that's it. That's all you have to do on this one. And it's another question. Someone who is 5 feet tall uses a potato gun to shoot a potato in the air at 100 feet per second. And the function h of t equal negative 16 t squared plus 100 t plus 5 is given to measure the height of the potato from the ground at any given second, which is t. Okay, so first of all, they want us to find out what is h of 1 and explain what this value mean in terms of the context. Okay, so h of 1, remember h is the height. Okay, so h is the height of the potato from the ground, and t is the time in second. So h of 1 mean at 1 second, how high will be the potato. Okay, what will be the height of the potato from the ground at 1 or after 1 second? See, so that's what that means. Okay, what is the height of the potato from the ground after 1 second? Now, again, before I did the video, so I went on decimals and just type in this function. They already tell us the function that model the situation. All right. So I went on decimals and graph the function, and I got this graph right here. So, and I also, found out all those points that we need to talk about. Now, so what I mean here on part A, at 1 second, what will be the height of the potato from the ground? So this is the y value, is the height. This right here, that's the height. Okay, so that's the y-axis, and this one right here is the time, and that's the x-axis. You need to know the time in order to know the height. Okay, so that's when your time is your independent variable, which is x, and your height will be your dependent variable, which is y, because your height depends on the time. So looking here, so at 1 second, which means we need to find out when x is equal to 1. Okay, we're going on the x-axis. We say, hey, that's 1 right here. So we find x equal 1 right here. So if I draw a line, all right, so when x equal to 1, we got that point right here. And that point is, when I click that point on decimals, it's telling me it's 189. So which means when at 1 second, that potato will be 89 feet from the ground. Okay, so at 1 second, that potato will be 89 feet from the ground. So we can say, well, h of 1 is equal to 89. Okay, again, after 1 second, that potato will be 89 feet from the ground. Now, they ask us, well, find h of t equals 0 and explain what this value means in terms of the context. So they want us to find the height. Well, they want us to find out if the height is 0, at what time. Okay, so here's the difference between port A and port B. In port A, we need to find the height. They give us the time 1 second, and we have to find the height based on that time. But on port B, we have to find the time based on the height. So they're telling us the height of the potato is 0. It's pretty much still on the ground. So at what time would that potato is at 0 feet from the ground? Okay, at what time? So what we need to do is find out where is y equals 0. We need to find where is y equals 0. So if I check over here, when y is 0, y here, y is 0, this point right here. So we're going to have, and also this point right here, y is 0. So here, the point is, so that's when y is 0. Okay, you guys can see that. So y is 0, that's 0. So we got this, that's this point right here, on the x-axis. Y is 0 always be on the x-axis. Okay, y is always be on the x-axis. So that's mean we got a negative 0.05. And also when y is 0, okay, you see you also got 0 here. On both of them got 0. So at that point right here, and x or the time is 6.3. Okay, now we have negative, we have a t equal negative 0.05. okay, that's when the height is 0, and we also have t equal 6.3. okay, now how do I know which one of this is my answer? We're talking about time. Remember, time cannot be negative, right? So time cannot be negative. So you cannot tell somebody, hey, it is negative 3 feet. All right. So because time cannot be negative, then this cannot be the answer. That negative 0.05 cannot be the answer. And so that leaves us with time equals 6.3. Okay. So at 6.3 seconds, the potato will hit the ground. Okay. So at 6.3 seconds, the potato will be 0 feet from the ground. Okay. So over here, and that's we are at the nearest thing. So if you do it in calculator, so we find like a bunch of numbers, so they want it in the nearest 10. So therefore this will be good right here. Okay, 6.3. So t equal 6.3 seconds. And the last question here we're going to talk about is the last one is C. About how high will the potato get? So the potato is like, that's what they want us to find out, like the maximum value. About how high will the potato get? So we need to find out what's the max. In other words, it's say like, what is the maximum height that the potato reach, all right, from the ground. So the maximum height will be like that. Let's say that the potato is going up, it's going up. So when you get to that point, boom, it's moving down, right? So that's mean the potato then go past that point, that black point over here. So that's my maximum point. And remember, this point is also called a vertex, okay? A vertex in a parabola is the maximum point or the minimum point. So we say the maximum point if the parabola open downward, and it is a minimum point if the parabola open upward. So in this case, this is a maximum, okay? And that maximum point is 3.125 and 161.25. So when they say about how high will the potato get, it will get 161.25 feet. That's the maximum height. So it will get, the potato will get 161.25 feet. At what time? When will that happen? So that's the time. So at 3.125 seconds. Okay, so the potato will get 161.25 feet at 3.125 seconds. And that's it. We just answer all three questions. We start just by going on Desmos and typing the function, and then analyze the graph and find everything that I need right from the graph. Okay, so that's good. All right, here's another question. Suppose that the equation v equal 20.8 x squared minus 458.3 x plus 3,500 represent the value of a car from 1983 to 2021. What year did the car have the least value? Okay, so assume, well, suppose that x equals 0 in 1983. Now remember, everything we have to represent, it's a real life story. So they come up with that equation, that function, okay, to determine the value of a car from 1983 to 2021. Okay, so they want to see at what year the car will have the least value. All right, so now again, I went on Desmos and type in the function, and that's the graph that came back. Because the graph that came back, and if you notice here, we have a parabola, and that parabola is open up. Okay, it's open up, and again, I expected that because if I look at the function here, the a value is positive. Now, if the a value, if this number in front of x is positive, your parabola will always open up. But if it is negative, it will open down. So the reason my previous question was open down is because the number was negative. Now, so I'm gonna make that as a note here. If a is 1 or greater than 1, if a value is greater or equal to 1, then greater or equal to 0, well, it cannot be 0. If a is greater than 0, then you have a parabola that's open up. Okay, the u gonna be open up. But if a is less than 0, then the parabola will open down. So now we got that set. Now what they tell us here is that we got from 1983 to 2021. Okay, so if 1983 is year 0, so that's what they're telling us, x is 0. So because you need to know that in order to evaluate it on the graph. Okay, so if 83 means x equals 0, so 84 will be x equal 1, 85 will be x equal 2, 86 will be x equal 3, 87 will be x equal 4, and so on and so forth. That's in pattern. Now, which means my year 83 is right here. That's 83. My here, where's 5? 5 would be 88. All right, 5 would be 88. And 10 would be 93. All right, and then 15 would be 98, and so on and so forth. All right, so that's the graph that's come back. When I type in this function, I got this graph right here. So they ask, what year did the car have the least value? Okay, when it's the least value, one word we can think of is the minimum. So what's the minimum value of that car, and what year does that happen? So the minimum value is the lowest point, is again the vertex. Okay, it's wherever the curve happen. Okay, so it's the vertex, so it's gonna be right here. Okay, since open down, we don't have a maximum, but we have a minimum, and that minimum is the lowest point on that graph, and then that's that point right here. And when I check on Desmos, that's the other pair I got, and that's my x value. Oh. So this is x value, and this is y value. Okay, so what that means is my lowest price will be 975.50 cents. Okay, so that's my lowest value. So that's my lowest value of the car. So 975.494. So, but what year does that happen? So we cannot have 11.017. So we're just gonna say year 11. Okay, so we're gonna say year 11. So forget about this. We're gonna say year 11. Now, once I know it's year 11, so I'm gonna say, well, if 1993 is year 0, so year 11, I have to do 1983 plus 11. Okay, so if you do 1983 plus 11, so that will be 3 plus 1 is 4, 8 plus 1 is 9, 9 and 1, so 1994. So that's mean the car have the least value in 1994. Okay, so 1994 will be your answer. So the car have the least value in 1994. All right, so that's it. All right, last question here. So the Vertex company uses the formula C equal negative 2n squared plus 2n plus 1500 to calculate C, which is the cost per computer of producing n computers. What is the greatest number of computers the company can produce for a cost per computer of $1,080? Now, this function right here model the price or the cost per computer of producing n computers. Okay, so what if n is the number of computer, and then C is the cost. So if you produce one computer, then you put 1 for n, and that will give you how much money you're gonna spend. If you produce 10 computer, you put 10 here, and that will give you how much money you're going to spend. So now the question is, what is the greatest number of computer the company can produce for a cost per computer of $1,080? So what that means is they give me that's the cost. C is the cost. Okay, C is the cost. So we know that from the question right here. So we know C is the cost right here. C is the cost, and N is the computer. All right. So every time they say money, then that's cost. Every time they say computer, then that's N. All right, so that's money right here in dollars. So that the cost. So we know C. We know C is equal 1080. So what they ask us to do is N. Okay, so if the cost is $1,080, how many computer can be produced? All right, so that's what we don't know. So again, before I made the video, so I went on Desmos again and graph this function right here. That's my function. I graphed on Desmos and I got that. So now what I did next is find the Y value. So again, remember this right here is the Y value. So the C, because to know the cost, I need to know the number of computer that's produced. All right. So that's how you charge a company. So so the Y value is the C, and the X value is the N. So I'm gonna, because I know C, which means I know Y, so I'm gonna go on the Y axis and look for 1080. So that's how I get my number. Okay, I first look for 1080, and once I find it, I click on it, and it showed me that X is 15. So how do I read this? The number of computer, if the cost is $1,080, the number of computer that can be produced is 15. Okay, if the cost is $1,080, the number of computer that can be produced is 15. So N is equal to 15. Okay, that's it. That's it. You know, with Desmos, you just graph thing on Desmos. That make life much more easier. Go to Desmos. Well, that's all I have for today. Thank you for watching this video. I hope it's helpful. Again, don't forget to like, share, and subscribe. If you have question or comment or suggestion, please let us know in the comment box. All right, so I'll see you next time for the next video.